Hello students, welcome back. In this part, we are going to learn about rate. What is meant by rate in general and how rate is defined for a chemical reaction. So let's start with the presentation.
Now throughout the chapter I will be keep on using a term that is rate repeatedly. So let's understand what is meant by rate in general, and then we'll see how the rate is defined for a chemical reactions. So basically rate is how much a quantity changes in a given period of time. So if suppose if any quantity is changing and how much is it changing in a given period of time, that is given by the rate. So you can see one of the simple example. This is an odometer which will indicate the speed of the car at every instant. You can calculate by looking at this. You can see what is the speed of the car at every instant during the journey. So the speed with which a car is driven is a rate. That is the distance a car travels in a given period of time. Say let's suppose in 1 hour the car traveled a distance of 100 kilometers. So the speed of the car is the distance traveled over time. That is 100 divided by 1 hour. That is 100 km per hour. This is the speed with which the car is driven. So the rate is distance by time. Yeah, this is in general. So let's see how this rate is defined for a chemical reaction. So rate of a reaction. Rate of a reaction is the speed at which the reaction takes place. So to understand it better, let's take an example. Consider this simple example where A is giving B. Okay. So during this reaction, A is consumed and B is produced. That is, amount of A is going to be decreased with time and amount of B is going to be increased with time. So you can say the concentration of A is decreased with time and concentration of B goes on increased with time. So here what is the quantity that is changing? Concentration. So concentration is changing with respect to time. So the rate of this reaction is defined as the change in concentration of A, reactant A, divided by the time interval delta T. And similarly here concentration of B is also changing. So I can also define rate in terms of B. So rate is equal to change in concentration of the product B divided by delta T over a certain time period delta T. So delta A and delta B represent the change in concentrations of A and B over a certain time period. But here the rate is positive. Rate is always positive. If you see the concentration of A is decreasing, so delta A is actually negative. So to make rate positive, we multiply it with a minus sign. So the minus sign over here indicates that concentration of A is decreasing. So delta A is negative. Okay, so this is how we can define rate of a chemical reaction, and the reaction rate can be defined in terms of change in concentrations of reactants or products. Yeah, to understand it even better, let's consider an example. Yeah, this is A is giving B a simple reaction, and here the container is there initially in which only A is present. So here to differentiate between A and B, the particles of A are in black color and the particles of B are in red color. Okay, so this is at initially at time t equal to 0, and it is the situation after every 10 seconds is recorded. This is 10 seconds and this is last, and the end 60 seconds. So you can see in this the situation of the reaction, the progress of the reaction with time. Okay, so initially these are the only particles of A present, and as time goes on increasing, the particles of A is decreasing. That is, the concentration of A is decreasing and the concentration of B is increasing. The number of red particles are increasing with time. Okay, so we can represent this change in a graphical form. Yeah, here on y-axis we are taking the number of molecules of reactants and products, and on x-axis we are taking time. So initially at time t equal to 0, the number of molecules of A are 40, and at the end at 60 seconds number of molecules of A is just 7. So the concentration is decreasing. Here the number of molecules are decreasing. Number of molecules of A is decreasing. That is, number of moles of A is decreasing. So if number of moles of A is decreasing, then obviously its concentration is decreasing, because the concentration of A is defined as number of moles of A divided by volume. If you consider this A as a gas, then the number of moles of A divided by volume will give its concentration. So concentration is decreasing, but here it is not concentration, but it is number of molecules that are decreasing. Similarly, you can also draw the concentration of A, the variation of concentration of A with time. You can also draw. Since here the number of molecules of A is decreasing, so concentration of A is decreasing and concentration of B is increasing. So the rate of this reaction is equal to the change in concentration of A divided by time. We can also define it in terms of products, that is change in concentration of B by time, and we can calculate this change in concentration, and this delta T is 60 seconds. So using this data you can calculate the rate of this reaction. Yeah, let's see in how many ways rate can be calculated. The rate can be calculated in two ways. That one is instantaneous rate, other is average rate. Instantaneous rate is the rate which is calculated at any given instant, at a particular point of time, at any given instant. But if you calculate the rate over a time period delta T, then that rate is called average rate. So let's see in detail what is meant by instantaneous and average rates and how we can calculate them. So instantaneous rate is the rate that is calculated over an infinitesimally small time interval. That is, say the rate of a reaction, see change in concentration delta C by delta T. So if delta T is taken as a very small, say it is approaching to 0, then in the limiting case, then we will get dC by dt. So this is the rate of a reaction, rate that is calculated at a point of time or an infinitesimally small time interval, and that is known as instantaneous rate. So if we know how the concentration is varying with time, so say if the concentration is varying with time as in this fashion, so at any given instant we can calculate dC by dt, that is the slope of tangent. Say suppose at this instant, at this particular point of time, I want to calculate what is instantaneous rate. So I can draw a tangent to this curve at this point, and I can take the slope of this line will give us the instantaneous rate, and it can be calculated in terms of reactants or products. Yeah, let's see how instantaneous rate is calculated for a chemical reaction. Let's do this example. H2 and I2 is giving 2HI. This is the reaction, and here the concentrations of the reactants and products are given. Here this is a green line which is the variation of concentration of hydrogen over time, and this is the variation of concentration of HI over time. Say I want to calculate the instantaneous rate, it says at 50 seconds, this is 50 seconds. So at 50 seconds I want to calculate what is the rate of this reaction. So what I will do is, yeah, on this curve at this point I will draw a tangent, line tangent, and this is the 2 points, the tangent is extended, and the slope of this tangent is simply tan theta. So tan theta will give the slope of tangent, and the tan theta is this change in concentration. So this is minus 0.28 divided by this is, say this is 40 seconds. From this triangle we can calculate the tan theta value, that is 0.28 by 40, so which will give the instantaneous rate at 50 seconds. And here the rate is calculated in terms of reactants H2, but we can also calculate in terms of products. Say this is the concentration of HI, the variation of concentration of HI with time. So at the same 50 seconds, at this point we can draw a tangent to this curve at this point, and similarly we can extend this tangent and we can build a triangle, and from this triangle we can calculate the value of tan theta, which is simply 0.56 by 40. So this is how the instantaneous rate can be calculated at any instant. Here I am calculating at 50 seconds. We can calculate at 85 seconds, 90 seconds, yeah, 10 seconds, like that. Okay. So the slope of the tangent at that instant will give us the instantaneous rate. So this is how the instantaneous rate is calculated. So let's see what is average rate and how it can be calculated. So average rate is a rate which is measured over a long time interval. we are not measuring over a small, very small interval of time, but we are measuring over a long time interval. Say if the concentration of the reactant or product is C1 at time t equal to T1, and at some other time T2, its concentration is say C2, then the average rate is simply the change in concentration, that is delta C, C2 minus C1 divided by delta T, that is T2 minus T1. So if you calculate this thing, it will give the average rate. Here the change in concentration of one of the reactants or products over the time taken for that change. So in this way, average rate can be calculated over any time interval delta T. Let's see how it can be calculated. Let's take an example. Yeah, this is the same reaction, that the hydrogen and iodine reacting and they're giving HI. So we can calculate the average rate over any time interval. So let's calculate it for first 80 seconds. This is first 80 seconds. So this is the T1, that is 0, and T2 is 80 seconds. So T1 is 0 and T2 is 80 seconds. So we can calculate, we can from the graph, at T1 the concentration is 0, C1 is 0, at T2 the concentration is 1.6, this is C2. So we can calculate C2 minus C1 by T2 minus T1, which will give us the average rate in this first 80 seconds. Similarly, you can calculate it over some other interval of time. So for first 80 seconds, this is the average rate, and similarly, if you calculate it over for first 40 seconds, the average rate is this much, and you can calculate even for 10 seconds also. So the average rate is calculated as this much. Okay, so in this way, average rate can be calculated over any time interval delta T, and here during the reaction, the concentration of the reactants decreases and the concentration of products increases. So to view this, let's take a video demonstration. Let's see how a chemical reaction will occur. Yeah, here we are taking a mixture of carbon monoxide and nitrogen dioxide in a round bottom flask. We are taking a mixture of carbon monoxide and nitrogen dioxide, and we have taken this mixture in a round bottom flask, and this flask is initially at room temperature. You can see here the color of the mixture is dark brown color, because nitrogen dioxide is in dark brown color. So the color of the mixture is dark brown initially. It is kept at room temperature in a round bottom flask. Yeah, now what we'll do is, now this mixture, this round bottom flask is kept in a container which contains oil at 500 Kelvin, and we are eating that. So a chemical reaction will takes place, and what you can do is, you can calculate the concentration of the carbon monoxide and NO2 after every 2 minutes. Here if you see, the color of the mixture is fading out. Initially it was dark brown in color, but now the color is becoming white. So the dark brown color is fading away. That means a chemical reaction is taking place and some products are starting to form. Yeah, the products are carbon dioxide and nitric oxide, CO2 and NO, and the color of the mixture is in white color. Now the mixture is in white color. That indicates that carbon dioxide and nitric oxide are formed, because CO2 and NO both are colorless gases. So initially the mixture was in dark brown color, but now it is in white color. So a reaction is taking place and certain products are formed. So if you record the readings of the concentration after every 2 minutes, then you will get a graph. This is the concentration of the reactants that is varying with time, which is decreasing exponentially. So during the reaction, the concentration of the reactants decreases, which we can see from this video. And similarly, the concentration of the products will increase. Yeah, this is the concentration of the products. Initially, products were 0, the concentration of products were 0, but now the concentration is increasing. So this is a graph which is showing the concentration of the reactants with time, the concentration of the products with time. You can see this is decreasing exponentially and it is increasing exponentially. So from this demonstration we can say that during a reaction concentration of the reactants decreases and concentration of the products increases, and thus we can calculate the rate, the instantaneous rate or average rate from this data.
So students, in this part we learnt about rate, how we define it for a chemical reaction, and in how many ways we can calculate its numerical value. So how to write the rate expression for a given chemical reaction. We'll learn more about this in our next part. Stay tuned in for my next part.